Hello, apes, and welcome to the 7th screencast in our series for Chapter 2. And Chapter 2 is the Earth's physical systems, matter, energy, and we're in the geology part. All right. So remember I said in the screencast 1 that you were going to do a plate tectonics book, and I'm sure that at this point in time we've talked about it in class. So now this is where your class time is going to be dedicated to starting this book and putting it together, and we'll do a couple of class periods with this. So we need to understand the Earth, and we're going to go through the different layers of the Earth. So we're going to start with the core of the Earth, and the core of the Earth is made up of solid iron, and the core is the center of the Earth. So it's the deepest inner core, the inner inside of it. The iron that surrounds this inner core, so if you think of a ball, the ball is the core and it's solid, that is surrounded by molten iron. So that means it's so hot that it is in a kind of a liquid form, kind of like more like a colloid type of liquid, where it can, or slime type of liquid. It's not a thin liquid. Okay, so then we have the mantle. The mantle is next to that core. It's less dense, and it's what we call elastic rock. And elastic because it can move. That mantle can move. My pronunciation of this next word, I massacre it every time I say it. The asthenosphere is in with that mantle as well, and this is very soft or melted rock as well, and this is where the area of geothermal energy is going to come from. And then the next layer is going to be the crust, and that's the thin, brittle, low density layer of rock that we're getting our fossil fuels out of. And then the lithosphere, and that's the uppermost mantle and the crust, and that's what we're walking on. That's what our soil's on. That's the one that we are in closest contact to. So let's go back and take a look at this little video that they have in here. So this shows you geological record, and hopefully it'll play or not. Do we have to move this along? Okay. I clicked play. All right. It didn't want to do anything, so we saw that wonderful picture. So here we are. This is what we're talking about as far as the parts of the Earth. So here is that inner core that we said is that really dense iron. And then surrounding that core is that molten iron that we were mentioning before. And then this next part is that mantle. And that mantle has the asthenosphere in it. And that asthenosphere, remember, it has the kind of like, I'm losing my terminology here, is going to have that melted rock, the magma, that we will be talking about. And then the uppermost mantle makes up the lithosphere. And that's where, as I said, we are doing our hydrofracking that I mentioned earlier, that we'll be talking about in more detail. And then we have the crust, the surface that we walk on. So that's the parts of the Earth. So what happens is, and I want to go back to this picture, notice our little continents that we have, and our continents are actually plates, and we refer to it as plate tectonics, and that's the movement of that lithosphere. They're plates that are made out of the lithosphere, and the way that they move is that they are driven by the heat from the Earth's inner layers. And that heat creates convection currents. And convection currents are currents that kind of go around. Oops, and I don't know why that makes those lines, but it keeps going around and around and around. And those convection currents actually push the mantle's soft rock up. And as it pushes it up, it warms, and then down as it cools. And that's kind of like a conveyor belt that keeps them moving. So what happens is this lithosphere then is dragged along the mantle. And that's why and I hope this picture is next. Yes, great. So when we see this, here's our major plates. Here's a major line for the plates, and we're going to talk about these boundaries where they move. But as you can see, South America, look at that. It looks like it was a chunk out of Africa. So at one point, these plates were joined together, and because of the shifting and the warming, they broke apart. So the early formation of this we called the Pangea, that you can see here. And here's where South America and Africa, North America was joined with Europe, just like the puzzle pieces going together. So let's go back one. So the Pangea was all the land masses that were joined into like this supercontinent, this big continent, and based on our geological evidence, that happened about 225 million years ago in the formation of the Earth. And as this heating and cooling and these convection currents happened, then we see the shift. We see the shift in the continents. And our continents are still moving. Costa Rica, as I said, is in this area, and that is still forming. There are maps where there's a space, a gap between South America and North America, that there's nothing in a little space there. And because there's volcanoes still active and rising and forming, the land is still forming in Costa Rica, as well as the Hawaiian Islands. And we'll see all of those changes and talk about those changes that take place. So as we saw, and I keep going back here, there are different kinds of boundaries. There's divergent boundaries, there's transform plate boundaries, and there are convergent boundaries. So let's learn about what those boundaries are. In divergent plate boundaries, this is where the magma is going to rise to the surface, and as it rises, it's what pushes the plates apart, and it actually creates a new crust. So this happens around volcanoes and the hydrothermal vents. So these are the places where we're going to see that happening. And we actually have an area off of the Philippines, and in this one area here and here, which is called the Ring of Fire. And that Ring of Fire is very active in volcanoes and the formation of islands. Okay, so transform plate boundaries are where two plates meet. So these plates can be moving together, and they can either cause a slipping or a grinding. This type of plate boundary is what produces the earthquakes along the strike slip faults. So let's go back to that picture and look at the transform boundaries. Runs right along here. That would explain the San Andreas fault, and they can either move to up and down like this, like my arrow's going, or they can strike and they can hit each other, and this can cause earthquakes. So our transform boundaries, look at this, we have a distinct one here, There's a transform boundary here. There's a transform boundary in this area and along right below the Himalayas. Okay, so you can see we have some distinct strike form boundaries that are present. Okay, so here we go. When we take a look at the divergent boundaries, and this is a really good illustration, you can see that we've got the magma that's in the asthenosphere, and the magma forces up, and this is what's going to, I don't know if you can actually see the rise here that's happening, this ridge, and this is what's going to create some of the islands and the land masses, where a transform plate boundary, the one that we looked at the San Andreas Fault, notice how it can move back and forth. So this is what it's meant to slip. This plate will move in this direction, this plate will move in this direction, and as far as the strike, they can actually hit each other. And this is what is concerning at the San Andreas Fault area in that transform plate boundary. So convergent plate boundaries are where plates collide, that literally they're coming at each other and they just, boom, hit each other. And we can look at this and we can call it subduction as one process. And this is in which the oceanic plate, so we're talking about stuff that's underneath the ocean, beneath the continental crust, that actually hit and formed the Cascades and the Andes Mountains. Okay, we can still, with convergent plate boundaries, have magma that erupts through the surface in volcanoes. So we know that the Andes Mountains has some volcanoes in that area. Then we have continental collision, and this occurs when two plates of a continental crust collide. And this is where we got our mountains from, the Appalachian Mountains and the Himalaya Mountains. So let's take a look at a picture of this. So this would be convergent. And notice that here's this oceanic crust, and it's going to be sliding under. Notice it goes under. That's what subduction means. And when it does, it pushes this magma up, and the magma can form the volcanoes along the crust. And we usually get right before the crust and the ocean this trench. Okay, so this is convergent. Convergent can also have the collision of mountains, where this continent is still moving along with this one, and one will go down and under, and it'll force up the mountains that we have. And that's how, as I said, the Appalachian Mountains and the Himalaya Mountains were formed. So when we talk about tectonics, this is what builds our mountains. This is what shapes our geography. You know, the ocean's not flat. The ocean has mountains underneath of it as well, in it as well. This is where we get our islands from in the different continents. And because of the shifting in these tectonics, this is where we get our earthquakes and our volcanoes from. So when we think about the land that we see, the topography that we see, that has been created by the tectonics shapes, and it also has impacted the climate in the areas. So topography alters the pattern of rain and wind. One of the reasons why we don't get a lot of big tornadoes in our areas, we have tornado warnings and we might get an F1 or an F2, but those mountains protect us and prevent strong winds from getting too fast and spiraling and swirling to create those tornadoes. So they can alter the wind and rain and currents. Kansas, which is flat, Oklahoma, which is flat, they don't have a lot of mountains. That's where we see Tornado Alley, because we can get those winds and the rains and the storm systems that can build up speed, that can collide and create these currents. It's also important in our heating and cooling. I see we're running out of time, so I got to quickly end this.